Hi, everybody. Welcome to topic number 12, introduction to probability number 2. So there are a couple more things I want to kind of introduce to you before we, start doing more probability questions. All right. So rules of probability. Okay, just a quick, some of the important rules. The probability of any event E. Probability of any event E. So I defined the event last time in a definition and concept. So if I have an event, okay, probability of the event must be between 0 to 1. The probability of anything happening, okay, got to be between 0 to 1. 0 means 0%, 1 means 100%. Okay, the decimal notation of 100% is 1. So all probability got to be between 0 and 1. Okay, so that's what this notation is saying. Probability of any event got to be between 0 to 1. Excuse me, that's 1 right there. The probability of all the outcomes, okay, probability of all the outcome must sum up to 1, which is sum up to 100%. We kind of see that. Let me flip back. Let me think back. We kind of know that when we introduce the cumulative relative frequency. Okay, so let me see if I can find when we went over the cumulative relative frequency. I think it's over there in topic number 5. Okay, so we introduce relative frequency where we count the frequency, we divide by the total number of the frequency. So if I will bring up topic number 5 real quick. All right, we did the frequency back in topic number 5. We did the relative frequency, right? So if I do a relative cumulative frequency, this will be 3 over 21, 5 over 21, 7 over 21, 12 over 21, 14 over 21, and 21 out of 21. So this very last cumulative relative frequency should be 21 out of 21. So that tell you the total number of probability in a way is going to sum up to 1. Okay, so if I actually figure out each decimal here for the relative frequency, and if you add them all up, it got to be equal to 100%. All right, so a second rule is probability of all outcome must sum up to 100%. If an event is impossible, the probability will be 0. Okay, 0 chance of happening. Okay, probability is 0. If an event is certain, then the probability event is defined as an event that has low probability of occurring. That is to say, probability is less than 0.05. So any probability that is less than 0.05 or 5%. Less than 5% it will be considered as unusual event. Okay. All right, determine the value that cannot be a probability. Well, 0 means 0%, that can. 0.9 means 90%, it can. Proper fraction is always between 0 to 1. Okay, so that's what the first rule says. All probability got to be between 0 and 1. So that's 1. Okay, 1/3 is 0.3 repeating, which is about 33 and 1/3%. So the one that cannot be is anything over 100%. Okay, the maximum probability can occur is 100%. Okay, so anything higher than 100% cannot work. Another thing I want to show you is something called a tree diagram. Okay, the tree diagram is a very special type of graph that can determine the outcome of an experiment. So the tree diagram can be drawn, for smaller type of experiment or for smaller type of event. Okay, so if you run into a problem where it has a lot of outcomes, then tree diagram is not that practical. So for small problems, for small events, tree diagram can help you can help you visualize what's going on and make the problem a little bit easier to solve. So here I want to show you how I can construct a tree diagram and find the simple space of having 3 children. Okay, having 3 children. So the way how it goes like this is like this. First thing first, 3 children, right? So first child, this is first child. Your first child, we know, can either be a boy or it can be a girl. Okay, that's the first child. Second child. Second child can be a boy or it can be a girl. This is second child. So if the first child is a girl, then the next child can be a boy or it can be a girl. Okay, now third child. If the first child is a boy, second child is a boy, then third child can also be a boy, or the third child can be a girl this time. If the first child is a boy, second child is a girl, then third child can be a boy, or third child can be a girl. You see where I'm going with this? All right. So this problem is not that difficult because each child only has 2 possible way of having them, boy or girl. So this problem is not as bad. Okay, so problem like these, the amount of simple space we have here, is not a difficult one. So if the first child is a girl, second child is a boy, then the third child can be a boy or a girl. If the first and second child are girl, then the third child can be a boy or it can be a girl. Okay. So so your simple space of having 3 children, your simple space, use a capital letter S, and we'll put our answer inside the set notation. That can be a boy, boy, boy. Okay. Another way is boy, boy, girl. Or boy, girl, boy. Boy, girl, girl. Girl, boy, boy. Girl, boy, girl. All right, girl, girl, boy. And the last one, girl, girl, girl. Okay, so that's my simple space. So 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 ways of having 3 children. Okay, so here are your simple space. So this is called a tree diagram. Sometimes in probability and statistics class, you will run into something called a Venn diagram. A Venn diagram is a picture represent the outcome of an experiment. It generally consists of a box that represents a simple space, just like this example right here. Big old box is a simple space. Okay, using letter S, together with circles or ovals inside of it. And the circle or the oval representing the event. So here I got 2 events, A and B. Event A is 1, 2, 3, 4, 5, 6. Event B is 6, 7, 8, 9. 10, 11, 12 is not inside of event A and B, but it's inside the simple space. So that's the way how you look at it. So the number 6 is in both events. Okay. So suppose an experiment has an outcome 1 through 12, where each outcome has an equal chance of occurring. So event A is 1, 2, 3, 4, 5, 6. B is 6, 7, 8, and 9. So this question will want me to find event A and B. Okay, so the notation is this. Find the event A and B. So the intersection, this is the notation for intersection. Event of A and B, okay, will be 6, because that number 6 overlap between the 2 events. So that 6 is in A and in B. Okay. Find events as in A or in B. So the word or in probability statistics means the event that's in A, or it's going to be in B. So the union here is the word or. The union sign is or, the upside down one is and. So A or B means what's, that means it can be in A or it can be in B. So what's in A? 1, 2, 3, 4, 5, 6, right? What's in B? Well, I'm not gonna write 6 again because it's either I can pick something from A or it can from B. So imagine an experiment where you will win if you draw something in A or draw something in B. So if I draw 1, 2, 3, 4, 5, 6, I win because all 6 number is in A. Or I will also win if I can draw things out of 6, 7, 8, and 9 out of the B. So 6 is in both of them, so we don't have to write twice. We can just continue, or I can pick what's in B, 7, 8, and 9. So you win if you can draw what's in A, or if you get what's in A or in B. So there's more ways to win, but and means it gotta be in both, right? That one specific outcome gotta be in both events. So chance of that happening is a lot less. So what's in A and B is only the 6. All right. 10, 11, and 12 are not in the event. So we consider those, okay? We consider those as complements. So I'm trying to see if I introduce that word yet. If not, I will introduce it. Let me flip back. I think I might have introduced it. Not yet. I have not introduced the word complement yet, but I will in the next couple of topics. I will begin to use the wording complement. It's a very unique concept. What a complement is. I will actually introduce it in the next topic. All right, let's look at the homework. All right, number 1 is copy from the definition concept from your handout. So, and what is an event that has a low probability of occurring? That is probability got to be less than 5%. So an unusual event. All right. Question number 2 is a multiple choice. You tell me which one of these 4 number cannot be a probability. Question 3 and 4 is coming from. Question number 3 and 4 is coming from. It's actually coming from the definition handouts. Question number 5. Consider the following tree diagram of flipping a fair coin 3 times. So it's very much just like the tree diagram I draw of having 3 children. Because if when you flip a coin, you only get 2 outcomes, right? Heads or tails. So I kind of draw this out for you already. You just need to fill in what's in the box A, what's in box B, C, and D for the next several questions. Okay, so these are multiple choice questions. So just real quick, kind of introduce more, introduce a little bit more about probabilities, like the rules of probability, tree diagram, Venn diagram. Okay, so those are the things that student does encounter when when you learn about probability and statistics. Okay, thank you for watching.